to Valenzuela Live Mathematics for Grade 8. I am here again, Sir Eldy Francisco from Jenny De Leon National High School, your FE Live teacher for the day. If on the previous topic, we have learned a lot about mathematical system and the two parts of it which are defined and undefined terms. Today is just a continuation of the lesson. We are going to discuss about the other two parts of mathematical system, which are postulates and theorems. And for our learning competency, for second week of quarter 3, you should be able to define and illustrate postulates and theorems, and prove theorems and mathematical statements or conditions using paragraph proof and two-column proof. But before we begin, let us first recall the parts of mathematical system. And what are those? Very good. The parts of mathematical system are undefined terms, defined terms, postulates, and theorems. The focus of our discussion for today will be about postulates and theorems. Now, let us define what postulates are. Postulate is a statement that is assumed true without proof, or statement that are generally accepted without proof. While theorem is a true statement that can be proven. And for us to be familiarized to the postulate and theorem, let us have a short activity. And this will be called replace postulate or theorem. All you have to do is to identify if the given real-life statements is a postulate or theorem. Just type your answer on the comment section. I will giving you a few seconds to think about it. Let's start with statement 1. Some students studying his or her lesson will have mastery of the subject matter and pass the subjects. Is it a postulate or a theorem? Your timer starts now. Okay? The answer is postulate. Very good. The statement is postulate because it is generally accepted. Because we know for a fact that when you study your lesson, you will pass the subjects, and of course, you will have a high grades. Next, statement 2. Sinovac vaccine shows an 80 to 90% efficacy rate within 2 months after 2 shots. Is it a postulate or a theorem? Timer starts now. Okay, good. So let us wait for the other answers. Time's up. The correct answer is yes, theorem. This statement is a theorem because it still needs data to back it up. Next, statement 3. Valenzuela is a part of National Capital Region. Is it a postulate or a theorem? Remember that postulate is a statement that is generally accepted without proof, while theorem is a statement that can be proved to be true. Comment your answer now. Nice. So if your answer is postulate, then you are correct. Very good. That statement is a postulate because It is a common knowledge that Valenzuela is a part of National Capital Region. Okay, next, statement 4. The sun rises in the east. Now, is it a postulate or a theorem? Comment your answer now. Okay, good. Again, let us wait for the other answers. Yes? The correct answer is postulate. Very good. The statement is a postulate because it is a fact and generally accepted as truth. Okay, next. Statement 5. The change in characteristics of a species relies on the process of natural selection. Is it a postulate or a theorem? Your timer starts now. Good. If your answer is a theorem, then you are correct. This statement is a theorem because it needs a proof to be proved. Alright. Thank you for your active participation. Now that you know how to distinguish postulate from theorem, we will now proceed to our lesson proper. At this point, let us illustrate postulate mathematically. So, let us begin. Postulate 1. Line contains at least 2 points. For the illustration, we have line E contains point W, X, Y. Or point W, point X, and point Y. Okay, next. Postulate number 2. A plane contains at least 3 non-collinear points, or what we call point existence postulate. For the illustration, point A, B, point C, and point D are on the plane M. Okay, good. Next, postulate 3, or what we call flat plane postulate. A plane contains, if 2 points lie in a plane, then the entire line containing those points lies in that plane. So this is the illustration. Point B and point C are on the line N, which lies on the plane M. Okay. Next, postulate 4, the plane intersection postulate. If 2 distinct planes intersect, then their intersection is a line. For the illustration, we have the distinct planes, plane Q and plane R, intersect at line N. Okay. This time, I will show you some other postulates that are commonly used in proving. Okay, number 5, segment addition postulate. If 2 points on a line segment AC, a third point B lies on the line segment AC if and only if the distances between the points satisfy the equation AB plus BC equals AC. For better understanding, let us assign values on the segments. AB is 3 centimeters and BC is 7 centimeters. And as you can see on the illustration, the measure of AC is very good, 10 centimeters. Or 3 centimeters plus 7 centimeters equals 10 centimeters. If we have segment addition postulate, we also have the angle addition postulate, which states that if point B is in interior of angle AOC, then the measure of angle AOB, plus the measure of angle BOC is equal to the measure of angle AOC. Or the measure of the largest angle is the sum of the measures of the two smaller ones. So for both segment and addition postulate, we can easily say that the whole is equal to the sum of its parts. Very good. Next, 7, or postulate 7, linear pair postulate. If two angles are linear pair, then they are supplementary. So this is the illustration. Angle 1 and angle 2 are linear pair, and with that, for any measure of angle 1 and any measure of angle 2, the sum is always 180 degrees. So they are supplementary. These are just some of the common postulates in geometry. There are still more postulates that will be discussed to you on your future lessons. Now, let us proceed to illustrate the theorems mathematically. Again, theorem is a true statement that can be proven. It can be proved by defined terms, postulates, or another theorem. There are actually various ways in proving theorems in mathematical system or conditions. But today, we are going to use only two of those, which are the paragraph proof and two-column proof. In writing proof, the properties of equality are also used as basis for reasoning. So let us recall all the properties of equality. We have the reflexive property, where A is equal to A. We also have symmetric property. If A equals B, then B equals A. And we also have transitive property. If A equals B and B equals C, then A equals C. And we also have substitution property, that if A is B or A is B, then A can be substituted for B in any equation. We also have addition property. If A equals B, then A plus C equals B plus C. Subtraction property. If A equals B, then A minus C equals B minus C. Next, we have multiplication property. If A is B, then AC equals BC. And last, we have division property. If A equals B and C is not equal to 0, then A over C is equal to B over C. I think with what we have discussed earlier, we are now ready to prove some theorems. First theorem. If point lies outside a line, then exactly one plane contains both the line and the point. For this theorem, let us use the paragraph proof. While proving, we will also use undefined terms as representation. Let us begin. Line K contains distinct points such as L and M at plane P. Okay. Thus, if point J is on the plane P, the that is not collinear to to points L and M, then points L, M, and J are coplanar. Therefore, a line and a point determine a plane. Very good. Okay, this is the first theorem. Next theorem, the vertical angles theorem, states that vertical angles are congruent. For this theorem, we are going to use the two-column proof. Okay? So let's start. So let us have the given. Line AB intersects line CD at point E. Angle AED and angle CEB are vertical angles. And this is the illustration. Now, prove that angle AED is congruent to angle CEB. Okay. Next. So we need a table. So first make a table with two columns. And on the first column contains the statements, and on the second contains the reasons. Alright. Okay. Then, for the first statement, you must look at or either to the given or the illustration. And for this situation, I will use the given as the first statement. Alright. Number 1, or statement number 1, line AB intersects line CD at point E. And what is the reason? Yes, very good. That is given. Okay. And for the second statement, we are going to have angle AED and angle CEB are vertical angles. Reason? That's also a given. Okay. Third, try to look back on the previous statements. Statement 1, statement 2. And observe the illustration. Right. That will lead you to the third statement. From the first statement, or based from the first statement, if line AB intersects line CD at point E, then angle AED and angle AEC are linear pair. And angle CEB and angle AEC are also linear pair. So what is the reason? Yes, the reason is definition of linear pair. So based on the definition. Okay, next, for statement number 4. Yan. If angle AED, so from based on the statement number 3, if angle AED and angle AEC are linear pair, and angle CEB and angle AEC are linear pair also, then measure of angle AED plus measure of angle AEC is equal to 180 degrees. And measure of angle CEB plus measure of angle AEC is also equal to 180 degrees. And what is the reason of this? Very good. Linear pair postulate. Right. Now, for statement number 5, we can base from statement number 4. So, since we substitute measure of angle CEB plus measure of angle AEC to 180 degrees of the first equation, since it is also equal to 180 degrees. Then, therefore, measure of angle AED plus measure of angle AEC. So, if measure of angle AED plus measure of angle AEC equals 180 degrees, and measure of angle CEB and plus measure of angle AEC is equal to 180 degrees, then the measure of angle AED plus measure of angle AEC is equal to the measure of angle CEB plus measure of angle AEC. And what is the reason? Yes, the reason is substitution property of equality. Okay. The reason can also be transitive property of equality. Because remember, if A equals B and B equals C, then A is equal to C. Okay? Next, for statement 6, based on statement 5, we can subtract measure of angle AEC both sides or to both sides of the equation. So, if measure of angle AED plus measure of angle AEC is equal to the measure of angle CEB plus measure of angle AEC, then, yes, the measure of angle AED is equal to the measure of angle CEB. Very good. What is the reason? Alright, the reason is subtraction property of equality. Very good. And for the last statement, if measure of angle AED is equal to the measure of angle CEB, then, yes, angle AED is congruent to angle CEB. The measure of two angles, also, remember, if the measure of two angles are equal, then they are congruent. And what is the reason of the last statement? Yes, the reason is definition of congruent angles. Very good. Okay, next. This time, let us try to prove some mathematical statements or conditions. Okay, so we have given Wx equals Yz. Prove that Wy equals Xz. And here is the illustration. Okay, again, we are going to use a two-column proof. So here is the table with the statements on the first column and reasons on the second column. For the first statement, we have Wx equals Yz. Okay? Right. Reason, obviously, given. Okay? For second statement, or for the second statement, try to think of it. Since we cannot construct another statement from the first statement, try to look at the illustration and create a statement that will lead you to prove the condition. Okay, let us use the statement xy equals xy. Xy equals xy. And what is the reason? Very good. That is the reflexive property of equality. Next. For third statement, this time let us base on the statements 1 and 2. Again, for the third statement, let us base on the statements 1 and 2. So, if Wx equals Yz and Xy is equal to Xy, then, yes, Wx plus Xy equals Xy plus Yz. Reason? Alright. Addition property of equality. And for fourth statement, we are going to base on the illustration and to the third statement. Illustration, third statement. Okay. So with that, we can construct the statement Wy equals Wx plus Xy. And Xz equals Xy plus Yz. And the reason is, yes, segment addition postulate. And for our last statement, based on the third and fourth statements, since Wx Wx plus xy is equal to xy plus yz, and wy equals wx plus xy, xj is equal to xy plus yz. Therefore, yes, wy is equal to xj. What is the reason? Okay, what do you think the reason? Yes, the reason is transitive property. All right, very good. Now, to wrap up our today's discussion, which you can also take a screenshot of the following important things to remember. So we have the mathematical system. A system composed of what? Composed of the following. We have the undefined terms that have no definition, but instead are being described or illustrated. And we have the defined terms, terms that are defined using undefined terms from the system. And postulates, statements that are considered true without proof or validation. And, of course, theorems, statements proved to be true using postulates, definitions, and other established theorems or logic. And we also use two ways of writing proof in our discussion, which are paragraph proof and two-column proof. We also recall the properties of equality that are used to prove some theorems and mathematical statements or conditions. Right? Okay, let us now proceed to the question and answer part. If you have any question about the topic, you can type any on the comment box below. You can type it on the comment box below. Okay? Okay. Let us wait for the question. Okay. So I received a question from one student through private message. Sir, what are the other ways in writing proof aside from the two that we had discussed? Okay, that is a good question, no? One of the other ways aside from the two is what we call the flow chart. Okay, so what we call the flow chart, in which the statements and reasons are organized by boxes and arrows. Alright? Okay, I think if you have further questions about our topic, you can note down your question and you ask your subject teacher on your follow-up classes tomorrow. And with that, that will be all for today. Thank you for listening and your active participation. Keep safe, everyone. Goodbye.